Hey everybody, welcome back to another fun and exciting geometry class. Today we are going to build on what we've been learning about deductive reasoning, and we are going to now kind of take the next step, which is actually, I'm excited for today, we are going to do a proof, a realty proof, okay? And so it's going to be a lot of fun. We're going to kind of get into some different stuff, creative stuff that you've never seen before in your life. So I'm excited about today. All right, well, let's go ahead and get started. You can look down. We are in your book on page number 47. So if you look on page number 47, you're going to see theorem number 1. Theorem number 1. Well, today what we're going to do is we're going to prove triangles to be congruent. So if I have two triangles, one triangle here and one triangle here, and I'm wondering, are those two the same? They look the same, but are they the same? Well, using geometry, we can prove that they're the same. We can make a proof. All the things that we've been learning already in the book, now added with some new ideas, and we're going to prove that these things are true. The way that we can do that is by using these theorems. All right, so here's the theorem. Theorem number 1. Theorem number 1 says, two triangles are congruent if two sides and the included angle are all equal to the corresponding side of the other triangle. That's called side, angle, side. So if I have two sides and the included angle, what does that mean? Okay, so if I have two sides to a triangle and the included angle, not the angle up here, not the angle away from, but the side, the angle that's included in the two sides, the connecting angle. If those three things are equal, so triangle ABC, and triangle DEF, if they have those equal parts, then this theorem says that they are equal. And we can use the initials abbreviation side, angle, side, SAS. Okay. Let's take a look. I have here in basically I've kind of taken and drawn a picture of the triangles that are in your book on page number 47. So if you'll look at those, here are the triangles that are listed on page number 47. And what you have is you have two different triangles that look to be congruent. Now, we learned just the other day that we can't really trust our eyes. We can't, say, oh, I think those are congruent. They look congruent. Okay, yes, those are congruent. That's not going to work. We have to use deductive reasoning to prove that they're congruent. So we have to say this, and then say this, and then therefore they are congruent. That's where we're going with this. Well, a couple things that I want you to think about. First of all, at some point, somebody has to give us some information. Somebody has to tell us something. Or we have to take and we actually have to measure the triangle ourselves. Remember, in geometry, we don't measure things. It's not part of what we do. We don't have a protractor. We don't have a ruler. Those are not part of our toolkit. Now, I know we do have one, and we will use it sometimes. But in constructions and in proofs, we never use a a protractor and a ruler. So how are we going to do this? Well, at some level, somebody's going to have to tell us something about these triangles. And if you look down there on page number 47, the book does that. The book gives you something. The book has what's called a given, okay? And in the given, it says triangles ABC and DEF. Now, that's important because they have to tell us that those are triangles. And you say, what do you mean they have to tell us that those are triangles? Remember, you can't trust your eyes. So maybe if you zoom in, maybe there's an extra angle in there. Maybe they're not triangles. Maybe it's like a really tight little angle and it's actually a quadrilateral. But we can't see it with our eyes because sometimes, depending on your perspective or depending on what you're looking at, it may look like a triangle, but we're not sure. In this case, we're pretty sure by looking at it, yes, those look like triangles. Now, the given says, yes, they are. They confirm that for us. But remember, we have to have hard and fast data. We have to have that in the given. They have to tell us that they're triangles, and they do. Okay. And then it says with, and then here's some more very, very valuable information right here. AB is equal to DE. AB is equal to DE. Now I want to show you what to do with this information. I'm going to put this in pink so you can see it good. What we do is we come over here and we do AB and we put one little slash mark on AB. And we put one little slash mark on DE. Why? Because what we're doing in our drawings is that way every time we look at this drawing, AB and DE are going to be like matched together. Those are equal to each other. So we put, now I mean you could put an equal sign on that if you want to and two slashes, but you'll see why in just a second that we're just going to use one slash for right now. Okay. Well, then we come to this next one in the given. We're still in the given. This is still given information. They told us this. We didn't measure anything. You know, we didn't get it from anywhere else except they gave it to us. AC equals DF. So now we go to the next one. AC, and let's put 2 on this one. So now equals DF. So now when you see the 2 together, they match each other. The 1 matches and the 2 matches. Okay, good. Now, what else did we need? When we went back to this theorem, we had 2 sides. Look at what else we needed. The included angle. The included angle. Let's see if they give it to us. Well, look at here. It's our lucky day. They gave it to us. They said A equals D. So now what I would do is I would come here, and if I was you, I would draw something like this on A and D. And then I would put, and on the angles, you can go back to just 1, because we might need to use 2 again for another angle. So we just put 1 on the angle. And if we put one little tick mark, one little slash on the angle, that'll tell us when we look at it, okay, those angles are equal. So look what we have. We now have angle, excuse me, we have, that's not an angle, we have side, angle, side. SAS, side, angle, side. And so now as we're proving this, we can prove this based on side, angle, side. Okay? Because they gave us those things are equal to each other. And now it says prove that ABC is congruent to triangle DEF. All right? And so what we're going to do, let's go up here and look at this proof. Let's actually look at what they give us. So this is on page number 47 there in your book. Triangles ABC and DEF with A in angle A and angle D and those sides. They gave us that. So what's the reason for that? Look over here. They put the reason is given. That's the easiest. This right here is the easiest points you will ever get on any quiz or any test in the history of the world. That's it. And every year, I mark those wrong because students don't write the given. Please don't do that to me this year. Please. Okay, please. I'm begging you. Every single time, the one thing that you know is what they give you. Step number 1, 100% of the time, every single time in every single proof. Step 1, write the given. The statement is what they tell you. The reason, given. Mr. Steve, that's so easy. I know. I'm trying to give you free points here. Okay? But every year, students don't take them. They don't listen. And then they don't write it in there. So please, write the given. Now, the second step here, the second thing is they say that, now this is like proving the proof. I don't know if that makes any sense, but this is proving the proof. This is like a proof of the proof. And so this is like what Euclid came up with. This is how he proved side, angle, side. Now we're not going to prove side, angle, side. We're going to prove different things with side, angle, side, and you'll see what I mean in a little bit. But I want to go through this because I want to show you his logic. So he said, if I place triangle ABC on top of triangle DEF, so that A falls on D, and that side AB falls alongside DE. He said, that way I can just move it. Now, here's what we're going to be doing. You have to come up with the reason for that. And Principle 5, Postulate 5, tells us that a geometric figure can be freely moved in space without any change in form or size. Now, I'm going to let you do something here. If you want to just put Postulate 5, this is the only one I'm really going to let you get away with. Because there's one more, but this one is the one. If we use Postulate 5 so much, if you just write P5, I'm going to know what you mean. Don't write P1, don't write P2, write it out, okay? That way, because if you don't, I'm going to be looking through my book for days trying to figure all this stuff out. Because remember, there's 83 theorems and postulates, and I mean, I can't keep up with all of it on every single test and every single quiz. So you write it out. You write out what it means. I'll let you slide on Postulate 5. We use it so much, so just put P5. It'll save you some time. So there's the first thing. Well, this is logic. So this is the first step. This is the all students in 5th grade wear blue shirts. Okay, the reason. The next thing that we're going to come to is AC. Then it must fall along on that side. Why? Because equal angles are all angles whose sides and vertices can be made to coincide. Definition of equal angles. And you have to go back in your book and find these definitions. We didn't memorize, we didn't learn these definitions for the fun of it. We need these. These are things that go into our toolbox so that we can solve these. Number 4, point B must coincide with point E, and point C must coincide with point F. Why? Because equal line segments are line segments whose endpoints can be made to coincide. That's the definition of equal line segments. And some of you are thinking right now, but everybody knows that. Okay, you have to pretend that nobody knows anything, and you are proving every single thing to people who have never learned anything. You're proving this to somebody who knows nothing. Okay, you have to prove every single small point, even though you think, oh, everybody knows that. No, you know it because you learned it. You're teaching it to somebody else now. You're showing them why. All right, so the next one, then point CB must coincide with point FE, and why is that? Because through 2 points, one and only point straight line can be drawn. That's postulate number 1. And then the last one would be this right here, and this is what they wanted you to prove. If we go back down to this, they wanted you to prove that ABC is congruent to triangle DEF. And that's the final step, is that 2 plane figures can be made to coincide through their congruent figures. So if we made them to coincide, then they are congruent figures. Now, some of you are thinking, oh my goodness, you mean we have to do this every single time? I have to go through the steps to tell you that they're corresponding figures and that they're going to line up every single time? No. It's your lucky day, all right? Let's look down here at this. This is on page number 48 in your books. I'm going to come back to that corollary 1. So let's go to this right now because I think you're ready for this right now. CP-CTE. CP-CTE. Corresponding parts of congruent triangles are equal. So now that we've learned this right here, I am going to let you take this shortcut on every single proof. Every time that you need corresponding parts to like sit on top of each other, you can use this. You can say, okay, we already proved it one time. All corresponding parts of congruent triangles are equal. You just need to write CP-CTE. Just write these letters. Don't spell out the words. Save your time. So you can use postulate 5, and you can use CPCTE. Corresponding parts of congruent triangles are equal. We proved it one time. Now we don't have to keep proving it every single time. So that's going to save you a lot of time, trust me. Okay? And some of you, your like mind is spinning right now. You're like, what in the world is this guy saying to me right now? Don't worry, we're going to keep working on this, and you're going to see this coming true. You're going to see this working itself out as we keep going through these things, okay? All right, one more thing that I wanted to share with you is also on page number 48, and I'll be done, is corollary. What is a corollary? A corollary is something easily deducted from a previous statement. So a previous statement was the theorem. Here is corollary 1.1. Two right triangles are congruent if their two legs are equal. Okay, so why does that make sense? Well, because if we have two legs, then we also have the included angle. What's the included angle? So let's do this. Let me show you two right triangles. All right, so there's a right triangle, and there's a right triangle. So if I can prove that their legs, remember this is the hypotenuse over here. This is the hypotenuse. These are legs. So if I can prove that those two legs are equal, let's say that these are 7, 7, if those match, and this one's 8 and 8. Now look what I have. I have side. I also have this angle. How do I have that angle? Because it's a right triangle. Those are both 90. So I have side, angle, side. In right triangles, side, angle, side is called leg, leg. That's all you need. LL, leg, leg. All right, man, there's a lot of stuff there, wasn't there? You might need to watch that video like 12 times to try to figure all of it out. All right, well, you keep doing your best. Keep trying to sort all that stuff out. And we'll continue to talk about this, and I think it'll become more and more clear the farther that we go through this. But maybe after today's lesson, you're like, what is happening right now? Focus on the things that we talked about. Side, angle, side, leg, leg, corresponding parts are equal, and all that good stuff. Okay? All right, we'll see you later. Have a good one. Bye-bye.